In the last exercise, we began to touch on some advanced partitioning techniques that we can use when installing Ubuntu Linux. We showed you how to take a single disk and to split the partition between a Windows operating system and a Linux operating system. That is probably the most common configuration to use. But what if your Windows disk is full and there's not enough space left to shrink the partition to add a Linux partition? At that point, your only real choice is to add a second disk into your system. Adding a second disk to your system is another one of those chicken or egg topics and may not really belong in a beginner's course, but since there are some people who may be in this situation that we don't want to leave behind, we will cover that here. And again, it's an advanced topic, but if you follow the directions, it should work out okay for you. Shown here is a CMOS/BIOS setup screen of a computer. Now, different brands have slightly different screens, so while we show you this one, which happens to be an American Megatrends brand of BIOS, there are several other brands, although you'll find that they are somewhat similar. So you have to look for the area that we're discussing, although it may be in a slightly different place than what you're expecting. If you're going to be adding a second drive, you no doubt will have to spend some time looking at the CMOS BIOS settings to make sure things are set the way we want. Now, in the previous lab, remember that we introduced to you the fact that there are two basic types of drives. The ATA, which is the legacy drive, which uses that wide parallel cable, and the SATA, which is the serial ATA or SATA drive. So if you're going to add a drive to your system, obviously the first thing you'll need to do is to figure out what type of drive your system has. Most of the legacy systems use the ATA, which is the drive with the wider cable. The newer systems use the SATA, which is that serial ATA drive with the narrow cable. And some systems will support both drives. Generally, it's easier if you stick to one type or another. Mixing drive types is not a topic I want to go into here, so I'm going to assume that if you have SATA drives, you'll be adding a second SATA drive, or if you have the PATA or the ATA, which is the wider cable drive, then you're going to be adding another one of those. Either way, as I said, you'll have to do something in the BIOS to make sure things are set correctly. If you're using the SATA ports, remember generally there are 4 SATA ports on a modern motherboard. And I believe they're labeled ports 0 through 3, with port 0 being the first one. You'll have to look very closely at the motherboard where the ports are to see the numbers. It's important to get the order correctly because at some point you'll have to tell the motherboard through the CMOS setting which drive you want to use as your boot drive. Here we see a close-up of the SATA ports. And if you notice, you can see the one on the right is labeled SATA 0. The one to its left is SATA 2. Now here we moved the cables and got in close again. You can see the one that's below SATA 0 is SATA 1. They're numbered top right SATA 0, lower right SATA 1, top left SATA 2, and bottom left SATA 3. You have to look at your system. They may not all be numbered in the same order on different manufacturers' motherboards. The term IDE, ATA, and PATA you may hear thrown around. They all mean the same thing. They all mean it's the wide ribbon cable IDE or PATA or ATA port hard drive, the legacy hard drive. Here we see a legacy motherboard. This is the primary IDE port and the secondary IDE port. Next to the primary IDE port is a floppy port, which if you look close you can see it's a little bit shorter. Generally you want your boot drive to be on the primary IDE port, although many times you can change that in the CMOS settings. Now remember, if you happen to be using the ATA, the legacy ATA, you'll have to make sure the jumpers are set correctly on your hard drive. Many times you'll have a system that will have two ATA ports. Remember, you'll have a CD-ROM on, so generally, many times in a new system you'll find the CD-ROM on one port and the hard drive on the other port, which means you could add a second drive to either of those two ports, providing you have the jumpers set correctly for the two devices. One has to be master, one has to be slave, or you can try the cable set setting. Now, whether you use the ATA or the SATA, it's important to know specifically which port your drive is on and which drive it is that you want to be the main boot drive for the system. Even though you may have Linux on a separate drive, only one drive can be set in CMOS to be the boot drive, and that's the drive that has to have the Grub bootloader installed on it. Different systems have different methods of mounting the hard drives internally. In this system I'm showing you here, there's a removable drive cage. We take out a few screws. This will hold several hard drives here, and then once we've mounted the drives in the cage goes back in the machine and gets bolted and snapped into place. And we saw this machine in the previous lab where there are two hard drives mounted directly to the chassis in this fashion. Your system may vary as far as how the hard drives are mounted in the chassis, but generally there's extra room and extra ports on almost any computer to hold additional hard drives. And of course, as we also mentioned yesterday, you have the option of using the drive drawer, which makes it easy to mount a hard drive in your system. Here's a system that has two drive drawers mounted in the front base. Now, just as a quick review, we want to show you the last installation. We can look at the partitioning scheme on that drive. It may make a little sense to you as we go through this, having seen this first. Let's look at a utility that can show us the drive partitioning scheme after the fact. We go to System, Administration, and the Disk Utility. Now here we see the Disk Utility, which can show us some useful information regarding how this hard drive is set up. This first partition shows us here it's an NTFS partition and it's bootable. An important part about the bootable partition, that's where our boot manager will be living. Here's our drive. Notice it's the only drive in the system. It's the first drive in the system, therefore it's /dev/SDA. The second drive would be /dev/SDB. The third /dev/SDC, and so on. Now importantly, it shows us it's 160 gig, and if we click this first partition here, it's a 51 gig NTFS partition. It's bootable. What we did during the install is shown on the right here in this graphical display. We created an extended partition, Dev SDA2. See that? This is Dev SDA1. So there's Dev SDA2. This is one big extended partition that contains Dev SDA5, which is our root. See, it says mounted at just a simple /, that's root. And this is our swap file, 4.5 gig. Generally, your swap file would be equal to the size you have in memory. This machine probably has about 4 gig of memory, therefore we have a 4.5 gig swap file. The intention is that we can take everything from our RAM and temporarily put it in that swap file. And that's Dev SDA6. So here is Dev SDA1, Dev SDA2, Dev SDA5, and Dev SDA6. There is no Dev SDA3 or 4. That's okay. This is just the way it's set it up. The important part is here's our Windows partition, Here's our extended partition that contains these two partitions, SDA5 and SDA6. Just a nice little reference to see as we look more and more at the advanced partitioning techniques. This will begin to make a little more sense as we go on. So in this example, we have a machine that supports the SATA drives. We have one drive in there already with Windows XP on it. We're going to add a second drive, an empty second drive, and on that drive we're going to install Ubuntu and make sure that we set the Grub bootloader correctly so it will boot either the Windows drive or the Ubuntu drive. Now, we will make a few notes regarding ATA along the way in case you're using the legacy PATA drives. Where it's relevant, I'll try and make notes that will help. The important thing will be in the CMOS where we set the drive that is the boot drive. Whichever drive is the boot drive will have to be the drive that has the Grub bootloader installed to it, regardless of what operating system is installed where. Having an external USB drive holder can be a very handy thing for cases like this. I have a drive that has something on it. In fact, that's one we used in an earlier experiment. I'm going to use the utility in working Linux to blow away what's on this drive so it'll be a totally empty non-partitioned drive when we start this next piece here. So we're going to use this other system here. Under System Administration, we have two disk utilities, Gparted and the regular disk utility. We're going to try the regular disk utility first here. And if we scroll down, we see on our, it says peripheral devices. I have a lot of stuff on this machine. Here's our 160 gig drive space. This is the drive we used in the last experiment. So what we're going to do is first we're going to unmount it. And then we're going to take this partition and delete it. This is a very final thing, by the way. Let's unmount that first. I'm sorry. Unmount that. There we go. You have to unmount everything first. That was mounted. So now we will delete the partition. We will delete this partition. We will delete our extended partition. And we will delete our original 51 gig. Now, obviously you don't do this if you have something on the drive you need. We'll delete that partition. And now we have a complete empty drive. We'll click this for safe removal and we'll take the drive out and we're done. These are very handy tools also if you're into this stuff. This is an external USB drive. I can always plug a drive in, plug it into an existing Linux system, and do basically whatever I want with this drive. This one you saw we just hooked it up and deleted all the partitions. So now we have a completely empty drive to start our new install with in this experiment. In the background you see we have another donor Windows system put together for this experiment and demonstration. And in this particular chassis we showed you earlier, we have a removable drive cage. So we're just going to slide our drive into the cage. It slides in just like this, very nice and easy. And then there's a couple of holes in the side that should line up with the drive to bolt it in place. Put our power cable and our SAT cable on. Of course, making sure the computer is not running when you do this. It should be powered off. And then we will put this cage in the chassis where it belongs. Again, your drives may mount differently. This bolts in. I'm not going to bolt it in now. It's going to leave it hanging in the breeze. Let's see if we get this stuff installed properly first. Okay, so we just added our second drive. First thing we want to do is make sure we understand which drive is which. So we'll hit, in this case, it's F10 to enter setup. Your system may be different. You may have to consult your specific computer manual. And let's go into our, first of all, let's look here. Now you notice we have 2 hard drives. And they're both the same model, so it's a little confusing, except that we know previously, we looked at this before, our first hard drive that we boot off is this one, number 1. This is the drive we added, and here's our DVD, okay? Again, look at this and make sure you know what's what before you do this. In the boot section, you're going to go to boot device priority. Obviously, you boot up the CD-ROM first, then the hard drive group. Now we have to go down to our hard drive group, and we want to select the first hard drive to boot off of. Now, even though you notice they're 0 through 4, it takes them in order. So if you have something in 1 and 3 as hard drives, it's going to take the number 1 as the first one, and number 3 as the second, skipping number 2 because number 2 may be empty. So you want to make sure we're booting off the first drive. That's our selection. Okay, so again, we're going to make sure we understand what drive is plugged into where before we start this, otherwise we get confusing and wind up wiping out the wrong drive. So now we want to put in our Ubuntu desktop operating system drive. Now if we made changes, we hit F10 to save and exit, otherwise we escape exit. Again, you have to look at your CMOS BIOS, it may be different. Escape. Quit without saving, it's up to you. In this case, I didn't make any changes, so I'm going to say yes. If you made changes, you have to hit save and exit. Now we're booting off our DVD CD-ROM. We now have our Ubuntu desktop, and coming soon should be our installer dialog. Here we go, we select English, we select install Ubuntu. All these items are the same as we've seen in previous labs. We'll let that go just as it is there. We want to get to the partitioning part because that's the purpose of this particular lab, is more advanced partitioning techniques for installing Ubuntu. Remember, this differs from the previous lab. In this lab, we're using a separate drive for our Ubuntu Linux and leaving our Windows drive intact. So we've just added a second drive to this system. Now, install alongside other operating system, erase and use entire disk, or specify partitions. We want to install alongside the other operating system. Let's see what we got. See, now this here shows us, here's where it's important, select drive. We want to pick our other drive here. We're going to pick our SDB drive. Now, here's where it's important. The entire disk will be used. It's going on there. We're going to click install now. Now we should, I'm curious to see where Grub goes. I haven't seen a dialog yet asking about Grub. That looks like it's happy so far. We'll select our area and we'll let this continue. We may see some different dialog when we get to the Grub installer. Let's see what happens. Meanwhile, it's pretty much a regular install. Nothing different than we've seen so far, except we picked a separate drive to install the Ubuntu. We're leaving the Windows drive alone. And we're on with our install. As you can see in the background, our Ubuntu is installing. I'm expecting a dialog near the end though, or something regarding Grub. I don't know if Grub will automatically know to install to the first drive in the system, which is the boot drive, or it will ask us which drive to install to. The point is, we need to install Grub on the drive that the system is set to boot to. So let's see how the install goes and see if we get a dialog regarding that near the end. Okay, we were not prompted for an additional grub setting, so we'll see if this works. Remove the installation media and hit enter to continue with the restart. Let's see if we get a grub bootloader or not, if we knew where to put it. It looks apparently as if the bootloader worked fine with Ubuntu going on the second drive. And there's our friendly bongos and our login. And here comes our Ubuntu desktop. Looks like we have success. So let's restart and see if Windows will work. In this case, we're going to select our Windows loader on device SDA1. And this looks like our Windows survived our Ubuntu install. Looks like we're happy here. What we'll do next is reboot back to Ubuntu and see if we can access our Windows files from Ubuntu. Here we are. Here's our login. And if we now look at places, we see an extra 160 gig file system, which is our Windows partition, our Windows drive in this case. Remember, we have a whole separate drive here. Documents and settings, my documents. Here's a Windows Word document. You double click that and guess what happens? It opens up in OpenOffice Writer. Pretty good, huh? What else happens? Here's an Excel sheet. Double click that and look what that does. That opens in OpenOffice. And here's a PowerPoint presentation. And looky there. That opens up in OpenOffice. So as you can see, once again, it was a relatively easy transition from Windows to Ubuntu. And in this lab, we were able to add a second hard drive, a second empty hard drive, and install our Ubuntu to that drive. And the grub was smart enough to figure out, since we told it to install alongside the other operating system, it was smart enough to figure out how to make a bootloader for us that will load either the Ubuntu or the Windows. So now it's up to you. If this is the type of installation that you want, you can refer to the detailed instructions below. and perform this type of Ubuntu installation on your system.